moving. So once again we come back. Today's physics lesson. Let me teach you something about, once again, a quick revision of work, power and energy. See, this chapter you have been studying since class 8. In class 10, there is nothing big magnified hidden over here. In Icse, I will be teaching you as per the Icse syllabus. So we are doing something brilliant, big things. The same thing that you studied, we will be studying the same thing or revising the same thing in a better, refined way. So first of all, let's understand about work. When we studied about work, we understood whenever a force is applied, if there is an object, and whenever a force is applied, and there is a displacement, we used to say work is done. Right? So we used to understand when we say work equals to force into displacement. Please understand, we are talking about displacement, not distance. So whenever we apply force and there is a displacement, we used to say work is done. In class 10, we will define the same thing. Right? Now this displacement, what we are talking about, it can be in many directions. So how do I measure the amount of work done? We will refine our definition from this W equals to F into S. Let's see. This is not wrong. We will come back to it. So what is work done? Work is said to be done whenever a force is applied on an object. Work is said to be done whenever a force is applied on an object and there is a displacement of the object towards the direction of the force. How much displacement? When we are talking about displacement, that means the object comes here. That means we will consider the displacement from here to here to here, or from here to here. Which one? This question. So let's redefine the definition in this way. We will say the amount of work done by a force is equal to the product of force. The amount of work done by a force is equal to the product of force and the displacement of what? Displacement of point of application of force towards the direction of force. From that means from here to here. This is what is the displacement you talk about. I redefine once again. So what we are saying? The amount of work done by a force is equal to the product of force and the displacement of what? Displacement of point of application of force. Which way? Towards the direction of force. So this is what defines what is work. So we understood how what is done. So we understand that work done by an object is dependent on two things: the magnitude of force and the displacement. Once again, the displacement of what? Displacement of point of application of force, which way? Towards the direction of force. But is it necessary always that I apply a force over here and the object is displaced this way? Just for example, I'm just showing you an example over here. I have an object over here, right? I got an object over here. I apply a force, F. So this is my point of application of force. So what we understand from work done? Work done equals to magnitude of force into displacement of what? Point of application of force towards the direction of force. But I applied the force. This was my direction of force. The object did not go this way. Instead, the object went that way. Now how do I find out the work done? So the object came here. It happens. Suppose we kick an object, it went the other way. What happens? So how do I find out? So in these cases, you need to find out a component of force. Don't get worried about components. So here, this is the displacement. I need to find the displacement towards the direction of force. work done equals to F into S. That means the force and the displacement has to be in the same direction. But here the displacement is in some other direction. Force is in this direction, displacement is in some other direction. That means I need to bring the displacement towards the direction of force. So, how do I bring it? Let there be an angle of theta between the direction of force and the displacement. Okay? So there is an angle of theta between the direction of force and the displacement. Now I'll apply trigonometry over here. Please recollect your trigonometrical skills so that you understand it better. So I need to bring this one this side. So what can I say? I can say cos theta equals to base by hypotenuse. Remember? Cos theta equals to base by hypotenuse. Now let us consider this triangle A, B, C. Right? I need to bring this displacement towards the direction of force. So what can I write? Cos theta equals to base is what? Basic BC. I need to find out what is the value of this. Hypotenuse is how much? S. So therefore what is BC? BC will be how much? S into cos theta. So ultimately, if I bring this displacement towards the direction of force, it becomes S cos theta. So what is the work done? So the work done will be force. Now this has become S cos theta into S cos theta. Now we can see a new formula for work done. Work done equals to force into S cos theta. F into S cos theta. In fact, don't misunderstand this one. See, it is not necessary that you have to bring the force towards the direction, displacement towards the direction of force. You can also take the force towards the direction of displacement. Did you understand? So we understood that work done depends on three factors. One, previously we understood it depends on two factors only. Force and the displacement. Here we understood it depends on force, the displacement, and theta and cos theta. What cos theta? The angle between the direction of force and the displacement. See, I told you it is not necessary to bring the displacement always to the direction of force. You can also take the force towards the direction of displacement also. I can do the same thing. Just come back to it. I hope you understood this one. Please note it down. So we will do the other thing. We will bring the force towards the direction of displacement. Let's see what happens. I am using the same diagram. Okay. So I applied the force on the object. It made an angle theta and the displacement with the other thing. So if this is theta, this will also be theta. Right? If this is theta, that is also theta. Right? Now, this is my force applied. Let me draw a perpendicular from here. Let me draw a perpendicular from this point to the displacement. So here, this is theta. This is my F. This is theta. This is my force. And here, this is my perpendicular. Right? Got it? Now, I need to bring this one to this side because both the force and the displacement has to be in the same direction. Once again, we will apply cos theta equals to base by hypotenuse. What is my hypotenuse over here? My base is this. This is my base. So base, hypotenuse is what? F cos theta. So base becomes what? Base equals to F cos theta. So once again, this becomes F cos theta. So work done equals to F cos theta into S. So it's the same thing. Work done depends on three factors. Please remember the three factors. What are the three factors? One, the magnitude of force. Second, the magnitude of displacement. Third, the cosine of the angle between the direction of force and the displacement. So these are the three factors on which the work done depends. See, lately I am using over here the cross sign or dot sign. See, as it is not in your syllabus, I am not discussing about something called cross product and dot product. In fact, work done is written in this way: W equals to F into S. This is a dot product. Okay. So let's ignore that because it's not there in syllabus, so we will not ignore. So just remember, depends on three factors. W equals to F S cos theta. Now we will understand when the work done is maximum and when the work done is minimum. Let's come to it. So we already understood the work done by a force on an object is dependent on three factors. The three factors are force, displacement, and what? And the cosine of the angle between the force and displacement. Now, special cases. Let's see. Now this angle may be anything. Depending on this angle, the value of the work done changes. Right? So, let's see, W equals to F into S cos theta. Right? This is what we understood. W equals to F into S cos theta. So, if theta equals to 0 degree, what happens? If theta equals to 0 degree, now what will be the value? We know cos 0 equals to 1. So W equals to F into S into 1. That means once again F into S. This is the maximum amount of work done. So remember, when is the work done maximum? The work is done maximum whenever the angle between the force and the displacement is 0. That means I have an object, I apply a force, and the object is moving towards the direction of force. The angle between the force and displacement is how much? 0. The work done is maximum. This is what is asked in exam. Please remember, very, very important. So the condition for work done to be maximum is what? The angle between the force and the displacement has to be 0 degree. That means cos 0 equals to 1, F into S, cos theta, that means F into S 1, W equals to F into S. Now let's see what happens in this first case. There are several examples, I'll come back to the examples. Next, another case, if theta equals to 90 degree, theta equals to 90 degree, that means cos 90. What is the value of cos 90? Cos 90 value is 0. That means work done equals to F into S into cos 90. That means F into S into 0. Work done equals to 0. Whenever the angle between the direction of force and displacement is 90 degree, the work done is said to be 0. Got it? So remember, this is the maximum amount of work and this is the minimum amount of work that can be done. Maximum and this is the minimum amount of work that is done. Please remember, some people take the negative work as minimum, not that. This is the one. Maximum amount of work is when the angle between the force and the displacement is 0 degree, and the minimum amount of work that is done is when the angle between the force and displacement is 90 degree. Right? Now there are several examples in your book. You need to go through the examples. I'll just go through the examples one by one a little bit. In the first case, when the work done is maximum, suppose a free fall of a body. A free fall of a body. When we are seeing free fall, suppose this object is over here. Now what is the force acting on this object? So force acting on this object right now, let me draw this picture over here. This is the surface of the earth, an object is over here. What is the force acting on this object? Its weight. Force acting is equal to the weight, that is equal to m into g. Right? So when I leave it, what happens? It comes down and there is a displacement taking place, h. The direction is the same. The direction of the force and the direction of displacement is the same. I take an object and I leave it. The direction of force is down, the direction of displacement is also down. That means, here what is the work done? Work done equals to F into S. What is the force? M into G. Displacement is how much? H. So the work done equals to mg h. So for a free fall of the body, when the body falls from a certain height, the work done is given as mg h. Right? Okay. Now suppose a coolie does a work on the load when he raises it against the force of gravity. Please understand this. See, whenever people hear about coolie, they say no work is done. Please don't understand this in this way. Suppose I lift up an object. What am I doing? The object has got, suppose I lift up this duster from this surface to this surface. So there is a displacement taking place. At this position, what is the force acting? Once again mg. Weight is the force that is acting. The displacement taking place. So obviously work is done. So a coolie does the work on the load when he raises it up against the force of gravity. The force exerted by coolie mg and the displacement is h. Both are in upward direction. See, the force exerted by the coolie is mg. He is giving a force mg up. The displacement is also up. So ultimately he does the work as mgh. But please understand something. So this is the special cases where the work done is said to be maximum. These are the maximum work that is done. We are talking about special cases when the work done is 0. Let's see when the work done is 0. Suppose a coolie is carrying a load on his head. And moving. It's a coolie carrying a load on his head and is moving. So this is the displacement of the load. And what is the force acting? The force is acting through the center of gravity downwards. What is the angle between them? 90 degrees. So when a coolie is carrying a load and walking, there is no work done by the coolie. So when a coolie works horizontally while carrying a load, as the angle between him, so work done is how much? W equals to F into S cos 90. That means F into S into 0, that is work done is 0. So whenever a coolie is carrying a load horizontally through it, that means there is no work done against the force of gravity. Please remember, there is no work done against the force of gravity because the displacement of the load is normal to the direction of the force. Displacement is normal. Normal means 90 degrees to the direction of force. Yeah, got it? Similarly, whenever an object is moving in a circular path, suppose an object is moving in a circular path. I took a string, tied a stone, and I'm rotating it. Right? So here the centripetal force acts. Right? If I hit the string at that moment, what's going to happen? At every instances, the body tries to fly away in the tangential direction. This you have studied before also. That means the direction of the displacement and the direction of force is what? 90 degrees. So whenever the angle between the direction of force and displacement is 90 degrees, the work done is said to be 0. Right? Moreover, you consider the object is over here, it is coming back to this position. The displacement is 0. Though it is not a distance, it has covered the entire distance, but the displacement is 0. So the work done is also said to be 0. A satellite is moving around the earth. The work done is 0 at an instant. Why? Because the angle between the direction of force and the displacement is 0 over here. So whenever a body moves in a circular path in a horizontal plane, no work is done since the centripetal force of the body is directed towards the center of the circular path. Centripetal force is directed towards the center of the circular path, and the displacement at all instances is in the tangential direction. Clear? Understood? So for this reason, it is for this reason in a circular path, the speed of the body does not change also. The velocity goes on changing. Why is the velocity variable? Because at every instance the direction goes on changing. You have studied about this one. So we understood there are two conditions when the work done is said to be zero. Work done is zero. When is the work done said to be zero? We understand W equals to F into S cos theta. See, either F has to be 0 or S has to be 0 or theta has to be 90 degrees. So these are the conditions when the work done will be 0. Either the displacement is 0 or the angle between the direction of force and displacement is 90 degree or the magnitude of force is 0. You do not apply any force. Right? Got it? So the conditions of work done by a force is 0 on these conditions. Right? Now, there is one more thing. Work done by an object can also be negative. Can also be negative. What it is? Yes. I hope you understood these two topics. What is this negative? We say work done equals to F into S cos theta. If theta equals to 180 degree, that means the angle between the direction of force and displacement is 180 degree. Then cos 180 degree equals to minus 1. So work done equals to how much? Minus F into S. That means if the direction of force and displacement is in the opposite direction, then the work done is said to be negative. That is not the minimum work. The minimum work is considered to be 0 only. Okay? So there are some examples given in the book about negative work also. When a body moves on the surface, now when a ball of mass M is thrown upwards, suppose the object is moved thrown upwards from A to B, from the ground, suppose this is the surface A and this is B. An object is thrown upwards. Right? Upwards, the displacement H is opposite to the direction of force. So in this condition, what is the force acting? The force is acting downwards, the displacement is upwards. So the angle between them is 180 degrees. The work done is negative. So there are some examples. We'll go through this work done once again. Right? Now, let us understand the units of work done. That is more important because you always when you are studying about work, you should be knowing about the units, the conversions of the units. These are important for you. You should be thorough with the units. Let's understand. Now we understood what? Work done equals to force into displacement. The maximum one we are considering. What is the unit of force? The SI unit of force is considered to be Newton. What is the unit of displacement? The SI unit of displacement is how much? Meter. So, work done equals to Newton into meter. That means what? If I apply a force of 1 Newton on an object, if I got an object and I apply a force of 1 Newton, and then the displacement of the object towards the direction of force as 1 meter, that means I can write down work done equals to 1 Newton into 1 meter. Then I see the amount of work done is said to be 1 joule. 1 joule equals to 1 Newton into 1 meter. Please remember this, very important. So what you see? 1 joule is the work done when a force of 1 Newton displaces the body through a distance of 1 meter. Which way? Towards the direction of force. Right? There are bigger units also. Kilojoule. Kilojoule is there. Megajoule is there. Gigajoule is there. So these conversion units are there. 1 kilojoule equals to 10 to the power 3 joule. Megajoule is there. 1 megajoule equals to 10 to the power 6 joule. These conversions you should be knowing. Okay? 1 kilojoule is 10 to the power 3 joule, 1 megajoule is 10 to the power 6 joule. Okay, so we understood the SI unit is joule. What is the definition of joule? We understood that. Now let us come up to the smaller unit, that is CGS, not smaller unit, the CGS unit of both.